In today's video we look at DIIS, a little-known extension of the Chernobyl SKALA computer created in the 90s. It was an unusual hybrid of vintage and then modern technology that gave operators convenient real-time control of the RBMK nuclear reactor. As you may remember from our previous episodes, the original Chernobyl SKALA was quite a superior machine in its stability and signal processing, and almost everything inside the reactor unit was connected to it. But it had limitations. It was not a real-time computer, it had ridiculously small operative memory and gave its output either on teletypes or on VFD displays. This was good for the 80s, but became insufficient in the 90s. Back then, the Chernobyl power plant continued operation with 3 remaining reactors. They passed deep modernization and became safe. But mostly due to political reasons, it was unclear how long they would be permitted to operate. So a complete replacement of SKALA was unreasonable, and therefore they chose a more pragmatic solution to extend the existing system. And this way DIIS, or an auxiliary information measurement system, was created. But to understand what DIIS is, let me explain a core concept. What do reactor operators refer to in their work? Well, in simple terms, 2 things. The first is a large volume of operative parameters that indicate what is happening inside the reactor. And the second is a reference model. Well, you may remember from the previous video that for every reactor there is calculated model of how rods inside have to be arranged, so the nuclear reaction works in the optimal way. It is loaded into SKALA, and basically SKALA works referring to it. Then there is the PRIZMA program that fetches live parameters and corrects this model, writing the changes onto magnetic tape. Because when the reactor works, conditions inside change over time. But now there is a problem. SKALA is a 24-bit machine from the 70s, programmed in machine code using punch tapes and this kind of consoles. So obviously you cannot integrate it with a PC right away. So they found an interesting solution. They installed a data bridge. It was SM1210 minicomputer. That is an HP 2000 compatible machine that was produced here in Ukraine in the 80s. It was connected to the shared memory of SKALA processors and could retrieve information that SKALA received from multiple detectors. And it also could access the PRIZMA tape. It was a neat solution because those SM machines were specifically designed to control industrial processes and integrate with other systems. But most importantly, you could program them already sitting in front of a display terminal like this, and do it in Fortran, COBOL, Pascal or BASIC. So, on the SM1210 there was running a special program that converted all this critical data and then sent it via special link to a gateway computer. I honestly do not know whether it was this one or that one, but it was a PC with 8386 processor standing somewhere in the SKALA machine hall. In its turn it was connected to a local network of DIIS based on ARCnet. The data received by the gateway was then transmitted to a file server that constantly accumulated a database of technological parameters. And then there were a few computers interacting with it already in a reactor control room. One for chief reactor operator, and this arm for a CRT monitor is exactly what remained from it. And another one was a computer for the physicist technologist. On them there were several programs called Dialog, Veter and Crater. Just saying, those names are acronyms. For example, Crater was a special algorithm that analyzed how energy inside the reactor was distributed in 3 dimensions. Additionally, it was also running on the gateway, but there it was triggered by a timer. So, to be short, these programs combined operative data from the file server, made necessary modeling and predictions, and then they presented all that in a visual form on a display. That was far more convenient than the original SKALA output. But apart from this improvement, DIIS helped to finally resolve a long-term headache. Remember I said before that for every reactor there was a reference model, basically a cornerstone of its operation. So the PRIZMA program could only detect changes and write them onto its magnetic tape. But this way, the model gradually moved away from reality. The solution? Well, obviously to compute it all from scratch. But SKALA physically could not do it. It was not a mathematical processor, but a control machine. So how was it done in the 70s? Approximately every week, data from SKALA was encoded onto a punch tape. The data from it then was sent to Moscow, to the All-Union Institute of Nuclear Power Plants, using some sort of slow data transmission line. There it was recalculated on a BSM-6 computer, and then in a few days the power plant received the new model back. It was then encoded onto a punch tape, loaded into SKALA together with accumulated corrections, and a new PRIZMA magnetic tape was created. And then roughly in 1 week it all repeated. Well, very efficient. So quite soon power plants started to build their own data centers where they had dedicated mainframes. At Chernobyl Nuclear Power Plant, if I remember correctly, it was yes 1020, an IBM 360 clone. It could do this job right on site and produce a compatible magnetic tape straight away. And when it was not busy, this mainframe could be used for many other tasks. But in the 90s it became possible to replace this gigantic mainframe with just a few personal computers and make the process even faster. But here was the problem: SKALA needed magnetic tapes. And so they made an elegant solution. These computers were linked to the DIIS local network. The data was converted by the SM1210 and written onto tape using its tape reel drives. So basically they only had to take the tape and place it into the dedicated SKALA drive. So this was a small but quite interesting page of Chernobyl history. Absolutely not the last though. And next time we will tell you an obscure story about websites that were hosted on servers located in the abandoned city of Pripyat. And some of them you can still access. So if you would like to have more stories like this, let us know in the comments. In the meantime, bonus content and updates on our projects you can find on our Patreon page. And we are very thankful to everyone who supports our work. Because that helps bring Chernobyl history back to life in a way it was never done before. And now, thank you for watching, and we will see you in the next one.